For those of you who have jobs, how many of you get up in the morning wanting to go to work? Or for those of you in school or tertiary study, how many of you get up looking forward to going in and learning more? When I was in my last year of school, I was told that 9 out of 10 people get up in the morning not wanting to go to work, and that you want to be that 1 in 10 who does. I've kept that in mind, and I've worked to get to my dream job at Emirates Team New Zealand. And that is a job that I most certainly look forward to going to. Today I'm going to talk about my journey to Emirates Team New Zealand and my almost 6 years with the team so far. Sailors and New Zealanders in the audience who follow the America's Cup will know who Team New Zealand is. However, for the rest of you, I've got a video which will play shortly, which should catch you up to speed on the history of the event. The America's Cup is the oldest sporting trophy in the world. However, it is as much a design and technology competition as a sporting event. As well as having the best athletes in the boat, you also need the best designers, shore crew, boat builders, engineers, and more in order to be successful. The video is now a little out of date, but it should catch you up on the history of the event.
170 years. That's a long time. 170 years ago today, the first car was still 35 years off. The Wright brothers' first flight, 52. That's 10 years before the start of the American Civil War. 45 before the birth of the modern Olympic Games. It's the year the refrigerator was invented. Times change, so they say. Well,
The America's Cup. The symphony of sea and sky and sail.
some things, they stay the same. 170 years ago, the oldest trophy in world sport was won for the very first time. A sailing race around the Isle of Wight in England. A radical-looking yacht called America beat the British on home waters and took the trophy back to the United States. The legend of the America's Cup had begun, and the winning of it has dominated the sport ever since. For well over a century, the New York Yacht Club welcomed challenger after challenger, but none could take the cup from the Americans. Until another radical yacht sailed into the history books again.
They have won the America's Cup. They have done it.
Just like the obsession to win, innovation in the America's Cup never stops. In 2021, the 36th America's Cup will be raced in a new class. You don't need to reinvent the wheel, they say. Sorry about that. We've reinvented the sailors too. A new breed of athlete, part machine, part scientist, engineered to perform at the edge. And the defenders this time? Watch out.
The America's Cup wrestles from the USA. The trophy belongs to New Zealand.
New Zealand have been on 6 America's Cup start lines in the last 7 editions. If there's a super team in this sport, these guys are it.
The America's Cup is now New Zealand's cup.
But keeping the cup won't be a walk in the park. Remember that 170-year-old drive to win? So, yeah, the America's Cup. Not your average sporting contest. For the 36th time, this is history in the making.
As you heard, the first yacht to win was called America, and the trophy was then made into a challenge cup where foreign nations could challenge and race against the strongest yacht from the defending nation. In more recent times, several countries have formed a single challenge, with the winner of that going on to race the yacht defending the defending nation. In 1983, Australia became the first country to beat the Americans, and then the Americans won it back until in 1995, New Zealand won it off the Americans. Team New Zealand then defended the cup in Auckland in 2000 before losing it in 2003 to the Swiss. In the 2017 challenge, the Americans were once again the defenders, and the event was held in Bermuda. This was the first cup that I was involved in, and as a team, we achieved our goals, bringing the cup back to New Zealand. Earlier this year, in March 2021, we defended the Cup in Auckland, and now we're in the early stages of the next campaign where we're trying to win the Cup for a third time in a row, which no country other than America has achieved.
Through school, my favourite and strongest subjects were maths and science. And at the same time, my favourite sport and the sport I spent the most time doing was sailing. And so I was sort of tossing up whether I give the Olympic pathway a go or versus going to university and studying engineering. And so one thing I realised myself was I wasn't really competitive enough sporting. So I really, really, really love sailing, but not enough drive to go to the gym 10 times a week and put like every last ounce into performing on the sporting field, whereas I'm probably more competitive academically. So for me, being able to combine my academic passions and my sporting passions at Team New Zealand is the ultimate. I believe foiling's the future. When you look out on the harbour now, you don't see windsurfers very often, except for when it's wavy, who are not with foils. They're all foiling round. It's exhilarating and the adrenaline's really cool.
The Kiwis, innovative in their design, intense in their focus, resilient throughout the time here in Bermuda. The New Zealanders pedaling into the history books. The America's Cup wrestled from the USA by Burling's men in black.
Bermuda was the climax of everything that all of us here at Team New Zealand had worked to achieve. Coming into it as a young person who had never been in a cup team before, and maybe it's my personality also, it's just quite optimistic, and in some ways, I don't know if you'd necessarily expected the outcome, but wasn't surprised when it happened and was like, oh yeah, cool, we've achieved our goals. But yeah, definitely the more emotional side, I'd say, was actually when we came back. Just thousands lining the streets in Auckland and Christchurch and Wellington. And people were like, why do these people actually all care about it? Why have they all come out and lined the streets and shouted and held up posters and stuff? And actually seeing that influence on a wider population and sort of the good feelings and positive emotions that it brings to so many people is probably when it really, really hit home what we've done. Everyone in the team's really here to win the cup. Like, people aren't coming to Team New Zealand in the morning to just go to work. You're going to, really work towards that biggest or one of the biggest goals in your life. And if it's something that you want to achieve and you put everything into it, you'll probably get there. So if you've got a dream, then follow it. But you've got to put in work to make it happen. You're not going to wake up one day and your dreams come true. But if you work to achieve it, then you most likely can get there.
I went into primary school with a bit of a head start in maths. My paternal grandfather taught at Teachers College, and he advised my mum on ways to teach young children. So my sandwiches were always cut into different shaped fractions. I'd open up a pea pod, eating some and seeing how many were left, and then using that to learn basic subtraction, and other maths fundamentals were learned through everyday hands-on activities. By being good at maths when I started, it made maths more enjoyable and made it easier to stay good. However, aside from that initial head start, I never did any maths externally to school. My introduction to sailing came through holiday programs at Takapuna at the ages of 8 and 9. And in them, I reached a level where the holiday courses couldn't offer me anymore. So my parents signed me up to Murray's Bay Sailing Club and got me my first boat, an Optimist. From the Optimist, I then progressed into the Starling and then mixed that up with some Bight C2 sailing in order to qualify for and then compete in the inaugural Youth Olympic Games in Singapore 2010. After that, I moved into a laser, which is both the Youth Worlds class, where the Youth Worlds is the pinnacle sailing event for under 19-year-olds, and also the women's single-handed Olympic class. Sailing is a time-consuming sport, and by the time I was in year 10, I was sailing at least 2 nights a week. On those evenings, I wouldn't get home until around 9 p.m. and would still need to eat dinner after that before getting into my homework. At the same time, I've always valued sleep and not working too late, and so through school, I never worked past 10 p.m. With the time constraints I had, it forced me to learn good time management skills while I was in school, and then these skills have set me in good stead going forward. During year 12, my mum took me along to an evening at the University of Auckland, which was promoting science degrees to high school girls. One of the speakers also made mention of her friend who was studying engineering, specifically engineering science. And what she said piqued my interest in the subject, and so when I got home, I Googled further to find out more about it. At that stage, I didn't really have a clue what engineering was. I thought it was about car engines, bridges, stuff that really didn't interest me that much. However, I've since learned a lot more about the breadth of engineering. For example, it's a great foundation for getting into finance, and there's a whole range of engineering roles from being very hands-on through to very much sitting at a desk with a computer and everything in between. So when I got home and Googled to find more about engineering science, and then on the homepage, I found 3 bullet points, one of which said, how can a sail be designed to work in low wind conditions? And with my sailing background, I just saw that and was like, this is the degree for me. I also had a dream to work at Team New Zealand. A lot of sailors undertake mechanical engineering degrees, and so I saw engineering science as something which would provide a point of difference and a slightly different skill set to those other sailors, some of which presumably also had ambitions of working at Team New Zealand. During my last 2 terms of year 13, I didn't sail and instead decided to focus on schoolwork, which really helped my mock and final international baccalaureate results. There used to be an option at the University of Auckland called the Accelerated Pathway, where you could go straight into your chosen type of engineering and straight into second engineering. This was something that I aspired to be accepted into, as it would mean that I wouldn't have to do the first general year and that I'd be able to complete my degree in 3 rather than 4 years. During that very end of school and in the summer holidays following, I also realised that I didn't really have the competitive drive to be successful at the Olympic level of sailing. While I absolutely love sailing and in recent years have sailed and raced my WASP as shown on the screen, I realised I didn't have the competitive drive to go to the gym 10 times a week and to have a real one-track mind towards Olympic selection and medalling, which is what you really need to achieve at that top level. So sailing at the top level was put aside. I was accepted into the Accelerated Pathway and into engineering science as my specialisation. What I was most worried about going into engineering was the programming aspect of the course, as I'd never written a line of code in my life. As we got into it though, I realised that the initial programming that we're doing in our papers was something of an extension of what we did on our graphics calculators at school, and that it wasn't really too scary after all. Engineering science is the engineering specialisation that has the most electives, meaning that there's the least prescribed papers, and so you can choose the most, which meant that I could really tailor my degree in the directions that I was most interested in. Within engineering science, there are 2 classical pathways, one of which is more about optimization, and the other is continuum mechanics. Continuum mechanics is more like the fluids and materials side of mechanical engineering. However, it's more about the derivations and the mathematical modelling and the computational techniques which go into solving problems. In order to graduate with an engineering degree in New Zealand, you have to complete 800 hours of work in industry. For my first summer break, I decided that first of all, I should try and find something in the sailing industry, as that's where I wanted to end up. So I talked to a whole lot of the parents at Murray's Bay Sailing Club who I knew had ties to the industry. Ultimately, it was through my dad talking to a past sailing coach, which landed me an internship with Pure Design and Engineering. Pure is an engineering consultancy specialising in the design of composite yachts, where composite means carbon fibre. My work there was using CAD software and Excel. CAD is computer-aided design, in this case, 3D modelling in SolidWorks. I also ended up working there for a second summer, and the most significant finished product out of my time there was a tool in Excel, which used VBA coding in Excel to drive SolidWorks. So the VBA code in Excel would take the SolidWorks model and chop it up and make cross sections along the boat, and then bring those 2D sections back into Excel, where a whole lot of structural engineering calculations were done to ensure that the design would meet internationally defined minimum structural requirements. With my goal of working at Team New Zealand and based on the papers I enjoyed most, I headed down the continuum mechanics side of engineering science. In particular, I was interested in aerodynamics and fluids modelling. So in addition to the EngSci papers which covered these areas, I also took the relevant papers from the mechanical engineering degree, such as the CFD paper in my final year. CFD is computational fluid dynamics, and fluids are liquids or gases. So CFD is using computer power to model the behavior of fluids, either in a static or, with even more computer power, a dynamic sense. In my final year, I also took the aerodynamics and hydrodynamics paper. This was part of what the no longer existing yacht engineering master's course, and the paper was 2/3 the same as the aerohydrodynamics paper, but then we split off to do stuff relating to yachts while they continued on doing stuff to do with planes. On the sailing side, after we split off, we had two significant projects. One was a wind tunnel project with a yacht model, and the other one was more challenging, but really interesting and probably the most relevant in terms of giving me insight into what actually goes on at a place like Team New Zealand. And that project was writing a 3 degree of freedom VPP. A VPP is a velocity prediction program. It is software which, given some underlying equations or physics models, says how to set up a boat so that it will go as fast as possible in a given wind condition and tell you how fast that is. The 3 degree of freedom refers to balancing only two forces in one moment. So the VPP is an optimization routine to maximize speed, subject to the constraints that the longitudinal and transverse forces balance, as well as the roll moment, which is the moment about the longitudinal axis. These are illustrated on the screen with reference to a WASP. This one project was really the most relevant, and it gave me the most insight into where I've ended up and the appreciation of the much more complicated models and computational power which goes into the VPP at Emirates Team New Zealand. In my final year of engineering, I also had an individual year-long project titled Improving Wind Models for the Chatham Islands. This was a CFD project using ANSYS CFX. The time management skills which I developed at school, plus the fact that my supervisor really pushed me to start writing early, really helped with this project. While it might be possible to cram for an exam, for a long-term project, it's actually all about the effort you put in over it. And so that meant that I had my final report written relatively early, and I got multiple rounds of feedback from my supervisor. The challenging part was 48 hours after the report was due, we then had to hand in the poster, and that was as shown on the screen. And we had a lady come in who had a lot more design sense than us in engineering science, and she gave us a bit of an introduction to Photoshop, told us about some colors that did or didn't work together, and then we're left to figure out Photoshop. And so that was about the latest I've probably ever worked, which was till close to midnight. We finally move on to how did I get to Emirates Team New Zealand. Remember Pure, the company I worked at during the 2 summers in the middle of my degree? They had strong ties to ETNZ. So midway through my final year of university, I got in touch with one of the directors at Pure, who I knew was also back working part-time for ETNZ, and expressed my desire to do anything at Team New Zealand in order to complete my last 200 hours. Obtaining an internship at Team New Zealand was a dream goal, and I wasn't really sure how achievable it was. I thought that working at Team New Zealand was maybe somewhere further down my career path. However, I figured there was nothing to lose by trying to get straight in there. With some persistence, I reached the point where I was offered an internship working at Team New Zealand from my final exam up until Christmas 2015. I was told that bikes were being considered as an alternative to conventional grinding, However, for that to be a reality, there were a bunch of hoops which needed to be jumped through, such as how the weight of the two systems would compare, how bikes could fit in the boat, and also another question was around the possible aerodynamic costs compared to conventional grinding configurations. My project during the internship was crew aerodynamics. CFD was used to evaluate different configurations, such as facing inboard, outboard, and on other angles. CAD, or computer-aided design modelling, was done in SolidWorks to generate the geometry, which was then run in CFD. To compare to the default options, I also ran configurations with standing, kneeling, and crouching grinding. Midway through my internship, I was offered an ongoing role with the team, and the crew aerodynamic project in particular was something that I returned to several times over the year and a half from then until the 2017 America's Cup in Bermuda. For the 35th America's Cup, in addition to the aerodynamics of the crew, I also worked on the aerodynamics of the fairings. There is an area, roughly shown in yellow on the screen, which was the area where fairings were allowed. However, there was a maximum planform area smaller than that total yellow area. So it was a case of deciding which of that area to use and then what shape to make the fairings in 3D. The bow triangle was all but defined, and it was apparent pretty quickly that you also wanted to maximize the size of the front beam fairings, as if those were larger, it meant that you didn't have to have as much trampoline. And trampoline is made up of a whole lot of little ropes, and those ropes are cylinders, and cylinders are draggy, so we wanted to minimize trampoline area. This then left trading off the aft beam fairing area with the central pod fairing. In addition to the CAD work for aerodynamics, I also made use of SolidWorks to draw parts for 3D printing. These parts are mostly for electrical housings and user input devices, such as Glenn's wing controller, Blair's slider, Pete's helm button housings, and other less interesting parts. This 3D printing role actually worked really well alongside the CFD because each CFD job typically took about 3 hours to run, and normally a whole lot were queued up to run at a time. So whilst I was waiting for CFD results, I could draw parts for 3D printing. And similarly, depending on the size of the part being printed, the 3D printed parts could also take a while to come out. So it was quite good bouncing between those two jobs when you're waiting for one or the other. I also did other miscellaneous work, with the largest of those probably again being CAD-based work. That was fitting the entire yacht and all the parts that make it up, plus all the parts required to assemble and deassemble the boat into a Boeing 747. With the use of 3D CAD modelling, it meant that we could really maximise the use of the space available and have parts that overhung each other, etc., to really fit as much in the plane as we could. While I was in Bermuda, there was still a bit of aero work going on and some 3D printing of spare components, but that work was tapering off. So I also got into some VPP work, looking at the trade-offs, such as being at the minimum or maximum end of the allowable weight range. While the VPP I wrote at university only had the 3 degrees of freedom, the software that we use at Team New Zealand, called Gombok, naturally has the full 6 degrees of freedom. The models that are either created externally and brought into Gombok or calculated within Gombok itself are also much better than what went into my one at university, and it can also be used for any kind of boat, whereas my one was quite limited. Watching the racing in Bermuda was nerve-wracking. There came a stage during the racing where they'd sometimes put the heart rates of the sailors up on the TV, and those of us watching in the base in the lunch tent, whenever they came up, would say that those heart rate monitors should be on us instead. So it was, yeah, quite nerve-wracking. However, the design decisions, top-level boat building, and top sailors all contributed to Team New Zealand winning the 35th America's Cup in Bermuda. Winning and celebrating with the team was amazing, but it wasn't until we got back to New Zealand and did the parades that I really appreciated the impact of our success on New Zealand and how many people actually cared that we'd won the America's Cup. It was snowing the morning of the parade in Christchurch. There were still all these people out of the streets, and it was really enlightening, realising the positive impact of sporting success on a national scale on the Kiwi population. On the return of myself and others to the team, we spent the spring of 2017 coming up with what the kind of boat would be for the next America's Cup. We considered all sorts of options and progressively ruled them out until we ended up with the twin T-canting T-foil boats sailed in Auckland this year. A yacht of this style, particularly with it being so large and the twin canting T-foils, had never been built. However, we had confidence in our simulation software. Gombok, which I just explained as being the software we use for the VPP, is also used for simulation. For the simulator, it takes the unbalanced forces and the mass of the boat and then time steps forward and accelerates the boat in space. Early last campaign, I was heavily involved building the simulator models of these different concepts of boats that we trialled, and then either sailing them myself or setting it up for one of the members of the sailing team who was occasionally around to sail it. Once the concept was finalised, a group of us wrote the class rule. This defines the scope of the design and provides limitations on what is allowed. Some areas were locked down, such as the weight, so that the performance of the yachts by the different teams would end up being somewhat similar across the wind range. Other areas were locked down to reduce cost, such as the one design rigging and foil arms. And then other areas were left open, such as the design of the sails and the control systems, as these were seen as areas where there was a lot of potential development, and also that some of these developments could trickle down to other yachts. From what you've heard so far, you'll appreciate that I have trouble answering the question of what a typical day looks like. As a young engineer, I've been lucky enough to work in various areas such as CAD, CFD, some software development, performance prediction, and pulling up the old proofreading and editing skills from English for the class rule writing. With the rule published and Emirates Team New Zealand starting the design of our own AC-75, I remained as the main person setting up the simulator models and running it with the sailors. However, I also picked up some of my old work of a bit of 3D printing and also running CFD on candidate Boat 1 hull shapes to look at how they'd compare from an aerodynamic perspective. As the time to launch Boat 1, Te Ahe, approached, I also picked up work in another area, the wind triangle. From on the yacht, we measure the wind. However, that is the wind seen by the sensor, not the true wind. The true wind is what an infinitely small sensor that is stationary would measure. It is an important number to get as accurate as possible, as it is this true wind that we use to compare our performance in reality back to our predicted performance from the VPP and simulator. So firstly, since we're measuring it on a moving yacht, we use trigonometry, matrices, and vectors to subtract the movement of the yacht from the measured wind. We also query a tide model to remove the impact of a tide, and then another correction has to be applied for the upwash. The upwash is the change in measured wind due to the presence of the yacht. The particles in the air can't go in a straight line. They have to bend to get around the yacht, and this changes the measurements that the sensor sees compared to what it would see if there was no boat. By the time Te Ahe was launched, I'd all but moved out of CFD and was soon to move away from 3D printing too. In addition to the increased VPP work, I'd done predicting performance and analysing performance in the simulator. With the launch, I also took on my new role of on-water performance. This meant that I was on the chase boat whenever one of our boats was sailing. During sailing periods, we'd typically be on the water about 3 days a week. And so on those days, I'd go down to the chase boat, check that the chase boat and the yacht were talking to each other, check that the configuration was right and that the wind gear was working. Then once we headed out on the water, I'd keep listening in to the comms going on the chase boat between other engineers and technicians and sailing coaches, and also listening to the comms on board the yacht and noting down anything of importance. After we returned to shore, myself and Ray Davies, the sailing coach, we ran the debrief, and then after that I'd return to my desk and run through some typical performance analysis that I'd do sort of every sailing day, as well as look into anything specific that had come up either on the water or during the debrief. Obviously, I'm not the only engineer at Team New Zealand. The design team numbered about 35 at the peak, many of whom have engineering degrees. Some, like those working in the areas of computer science, largely stay at their desks. The electronics and hydraulics engineers have a combination of research and design work at their desk, and then they also do hands-on work alongside technicians. The materials engineer runs some sort of science experiments on materials and also checks that the parts that have been built have no defects. The mechanical engineers design the moving parts, such as the foil flap systems and sail control systems. Personally, I'm a performance engineer, and the other performance engineers generally work more in the areas of aerodynamics and hydrodynamics, looking at the outside shapes of hulls, foils, and rudders. For this, they use the VPP to evaluate different candidate shapes. The structural engineers take those shapes and then decide what structure is required for them so that the boat doesn't break, whilst also keeping it as light as possible. Finally, the software engineers work using various different programming languages and work in areas such as improving the VPP and simulation software, developing the data viewer, and working on the software which runs on the yacht. Defending the Cup in Auckland was epic. It was so awesome seeing how many people were out on boats watching the racing. The support we received from the New Zealand population was incredible, and I felt really proud to be part of the team that provided such a great sporting event, which, even to the more traditional sailing audience, provided plenty of match racing manoeuvres just executed at high speed. During the celebration, when the chase boat initially went alongside the yacht, we became so surrounded by supported boats that it was actually really hard to get out of there after the champagne moment and dropping the sails. But it just really emphasised how excited the New Zealand population was that we'd won. And so, yeah, it was a really special afternoon. Working at Emirates Team New Zealand has allowed me to combine my academic and sporting passions. In saying that, it's not only about the work, it's also about the people. And they're a huge element of my enjoyment with the team. Everyone is really passionate about their job and winning the cup, so everyone will stay at work until the job is done and do their job to the absolute best of their ability. At the peak of last campaign, the team numbered around 150 people, but despite that, it's a very flat organisational structure and anyone can talk to anyone. No one is more important than the next person, and if you took any one individual out, there would be complications. Some of the design team have sailing backgrounds, others don't, but are experts in whatever areas they have come from. If you love what you do, you'll want to do more of it and therefore get better at it, which will make you love it even more. There are so many jobs out there in the world, so whatever your academic and extracurricular passions are, there will be a job out there which will suit you. You just have to figure out how to get there.
Hi, Elise.
Hello, how are you?
Good, thanks. Thanks very much for sharing your presentation. Great to see your passion for yachting and engineering both coming out. The IET is obviously very keen on encouraging the next wave of engineers and scientists. For this year, we've been focusing on a difference makers campaign, and we're glad you could be part of that. We've got a few questions that have come through and some other ones. Let's start with, perhaps you could explain the importance of teamwork in Emirates Team New Zealand.
Yeah, so I'd say Team New Zealand as a team, I mean, we have it in our name. It's really a huge part of who we are. We're all working towards this common goal of winning the cup. And so the fact that everyone has the same goal we're working for, and we've got this date from years out of when it's actually going to happen. So there's that deadline in the sand, and of course we put in various other ones along the way before that. But it's how everyone's working together and that everyone appreciates what everyone else is doing as part of a team, and also the communication that goes into it. So where maybe historically, if you look back a few campaigns, there was more a case of the designers design a boat, they give the drawings to the people building it, and then that gets handed over to sailors to sail. Now it's a much more connected process. So yes, the sailors are the end stakeholders, and then as a result, they're really involved in the design decisions. And I mean, they're all very experienced sailors themselves. Some actually have engineering backgrounds or got partway into a degree themselves. So they're very good technically. And so there's always discussions through the levels, and same with people manufacturing, whether it's the boat builders doing the whole boat or whether it's specific components being machined, where there's always feedback loops and really strong communication within the team.
Okay, cool. Okay, combining a couple of questions. You mentioned thinking that engineering was about car engines and bridges at one stage. How do you think we can better promote engineering and STEM in general? And how would you inspire others to follow a career in engineering? And really, how do we get past the stereotypes?
So I think, you do your subjects in school. You know what maths is because it's a subject you do in school. You know what chemistry is and biology and physics, but you don't know what engineering is, or at least where I went to school and what I've heard of in New Zealand, there is no engineering school subject. So unless maybe you have a parent who's an engineer or an older cousin or someone else, somewhere else, like how do you even know what engineering is? So I guess it's the education and whether that needs to be kind of maybe brought into the physics or chemistry or something curriculums a little bit, or whether it's, good information evenings, or during school assemblies, maybe having speakers coming in who actually give some insight into how broad engineering is, because it's huge. Like I know, speakers earlier today speaking about the shortage of software engineers, and, there's all these types of engineering, and it's huge, and there's plenty of demand, and it's across all the different industries, like whether you're into a particular sport like I am, or whether it's something else. There's just a huge breadth of opportunities that exist within engineering as a whole. So it's just becoming informed that those things are out there. You don't know what you don't know.
Yeah, it's really interesting actually. There's something in the UK, the IET only in the last day or two wrote an open letter to the government trying to get engineering into primary schools as a subject, or certainly something that greater awareness at an earlier stage as possible. So yeah, good points. A technical question about sailing. With such optimized craft, what's the balance between extensive design simulation versus engineering judgment in design?
So I guess, we sort of have a timeline. We say, well, we need to have a boat on the water in time to race, and you're going to go some time back before that to test it. And then you need the time before that to fit out all the electronics and hydraulics on it, time back from there to start the build, behind there to the structural engineering, and before that they need the shape they're going to work with. And so I guess within the team, we really try and push the timeline as much as possible, and in some ways are quite flexible. So instead of getting to a final hull shape and then handing that over for structural engineering, instead we try to have more of an iterative and fluid process where there might be a candidate hull that gets some preliminary structural work done and sort of feeds back in. Maybe there's some other shape changes that should happen as a result to save weight, for example. And just kind of feed stuff through. And like talking about with teamwork earlier, for example, the naval architects drawing the foil shapes, they sort of sit back to back with the guys who do the mechanical foil systems within the foil. So there's that constant sort of dialogue between, if we make this smaller, what would that mean? Can the system still fit? Or would have to go to this other thing, or would mean it would move slower? So yeah, it's that real sort of fluid process to really try and get the most out of the time that we have, and to optimize as much as possible.
Okay, that probably leads on to another question that someone's asked about what was the biggest engineering challenge on the AC75 that couldn't be optimized in time for the 2021 race?
I think as a spectator watching, it's pretty obvious that the four teams had pretty different hull shapes. So part of that can come down to what you were optimizing for. So if you were optimizing the boat for light wind conditions versus moderate versus heavy, the optimum solution will be different. So part of it comes back to how the teams weighted sort of at different conditions and what you're really trying to target the most. But I mean, there's historical data for Auckland's quite available, so shouldn't have been super different to each other. So I guess, yeah, looking at the hull shapes, for example, that would be an area where I guess, well, the class rule and protocol just came out yesterday, and that's, you know, put in stone that we are continuing with very similar boats. So I would expect to see, I guess, more convergence between the teams, and I guess part of it is the hulls are the biggest component, take the longest to build, so that timeline for where that shape was decided was quite a long time before racing, so probably about a year plus before racing. So, you know, there's definitely still work to continue with there. And then also probably not as visible to spectators, but some of the finer details. So water is 1,000 times more dense than air, so it's a lot more draggy, but it makes more lift. That's how the foils under the water are so much smaller than the sails. But it means that the details underwater are super critical, because if the pressure's such, not only, well, there's two issues you can run into. One is air getting sucked down through the water, and another one is that the pressure gets so low that the water vaporizes and turns to steam. So it's really, especially at the higher boat speeds, it's really important to try and get these details right. And the foils, they have a flap like on an aeroplane. So you've got your main section and then a flap, and really trying to get sort of transitions between those as smooth as possible, shapes as smooth as possible. So there's a lot of really fine detail stuff that there's certainly more work to continue with. So.
Okay. Was the Americans' crash an engineering failure or solely due to operator error? I guess you look at every incident in great detail, so I guess there must be an opinion on.
Yeah, it's not something that I could say that much on, not being part of the team. I mean, it was definitely some challenging conditions that they're sailing in. I mean, the boats are getting up to sort of 100 kilometres an hour. So, you know, things happen very quickly at that speed, and decisions have to be made very quickly. So, I mean, yeah, exactly what happened and how the boat landed was, I guess, a pretty unlikely occurrence or chance of happening. I mean, obviously things are different in hindsight, but I guess, yeah, that's what happened.
Okay. What's been the most exciting thing about working at Emirates Team New Zealand?
So I guess there's multiple aspects, but I guess something for me as a sailor coming into the team, you know, I'd watched the Cup in San Francisco in 2013 on TV, but actually coming into the team and seeing what's under the hood and how much technology there is, all the iterations, all of this stuff that's kept secret, because it is a competition and it is about having a competitive advantage. You know, it's not like, I guess, other areas where people are writing papers on things, or I guess not even really doing patents on things, because you're trying to keep all that IP within the team and to try and stay a step up ahead of your competition for the next event. So yeah, it's really cool being part of it behind the scenes in terms of actually knowing what goes on. And from the time I started and I was a new grad through to where I am now, because I've learned more from different people and I understand more of the different aspects that go into the boat, you know, it's an even greater, I guess, appreciation of the system as a whole.
Okay. Have you got any long-term goals that you're able to share? What do multi-America's Cup winning engineers do next?
Yeah, I mean, when we won earlier this year and we're going through the base and heading out towards where the presentation ceremony would happen, you know, in some ways, I guess I'm pretty lucky, you know, I'm 2 for 2, and whereas there's
but
other
a hat trick would be really good, wouldn't it?
Yes, yeah, that's the goal. So yeah, there's other people on the team who have been involved with several, you know, over a decade of America's Cups, and you know, Bermuda was the first time they won. So, you know, it does feel like I've had it a bit easy, I guess, coming in and 2 for 2, but yeah, the goals, yeah, keep doing the same thing, keep, I guess, pushing the technology out further and continuing to win it for New Zealand.
Cool. I guess each, you know, I guess each of those cycles is like starting a new job, because you've got, the rules are going to change, whether you're the holder or whether you're a challenger. It's new rules, new designs, and you're almost starting from scratch.
Yeah, and it was really exciting last time because it was this completely new concept. It was, you know, a big foiling monohull with canting T-falls, and when we actually saw it work, and even Ineos, or I think they were still BAR at that stage, when they launched their test boat, and it was the first of a type, and the fact it actually flew was kind of a relief, because while we've got great trust in our simulation tools and Gombok, you know, actually seeing it in real life is a bit of a relief. So yeah.
Cool. Guess finally, do you still sail competitively yourself, and how good are you?
Yeah, I mean, I guess my own sailing goes in cycles, I guess, opposite sinusoidal to cup. So typically, yeah, earlier in the campaign, I'm able to get in more sailing. And then as it gets to the business end and racing, then my boat goes into hibernation. So yeah, I'm actually president of the WASP class in New Zealand. And there's, I think, 60 odd boats in the country. Racing's been a bit far between and stuff with lockdowns at the moment, but hopefully, yeah, getting some more going. And yeah, I mean, I just really enjoy it, and the fact that it's just easy to set up and quick to go sailing. I definitely don't analyze my own sailing to the point that I analyze stuff at work. It's sailing for the fun of it, but I do definitely enjoy the racing aspect.
Cool. Well, it comes across that you obviously love your sailing, you love engineering, you love being part of Emirates Team New Zealand. So thanks very much, and good luck with the next cup.
Thanks, Andy.